Section 4.6, we're talking about absolute value. And if you remember what absolute value is, and most people do not know the actual definition, but they know how to apply it, which is fine, but the absolute value is the number of units that a number is from 0 on a number line. And so when we write absolute value, let's look at absolute value of 6 equals 6. The absolute value of a negative 6 equals 6. I am 6 units away from 0 whether I'm at a negative 6 or I'm at a positive 6. It doesn't matter. The negative is dropped because it's the number of units from 0. So make sure when you're applying the absolute value rule that it only applies to what's inside the braces or the brackets. Okay, if that negative is outside, and let's make that a negative as well. Okay, I have a negative absolute value of negative 6. So the first thing I do is get rid of the absolute value. But it's still a negative 6 because negative 6 absolute value is 6. The negative is outside. And now we know that it does not equal 6. So be careful of any operators that are outside the absolute value symbols because it's not included. Okay, so absolute value basically means that everything inside is positive. Well, we're going to deal with equations that use absolute value. Let's just look at an example. It might be the easiest way to look at it. If I have the absolute value of 2x plus 5 equals 11. Well, by rule, this can be positive or this can be negative, and the statement can still be true. So in order to get rid of these absolute value symbols, we write both possibilities. So 2x plus 5 equals 11. That's the positive possibility. And then the negative possibility is we just make the right side to be the opposite. So it's 2x plus 5 equals a negative 11, or 2x plus 5 equals 11. That means every solution could have more than one answer. And now we solve them individually, and we find that 2x, and we subtract 5 from both sides, and we get 6, or x equals a positive 3. And over here, I have 2x, and I'm going to subtract 5 and get negative 16, and x equals a negative 8. So my two possible solutions for example number 1 is a positive 3 or a negative 8. Now, if we were to put them in the equation, 2 times 3, absolute value, 2 times 3 plus 5, does it equal 11? 6 plus 5 is 11, so that is true. Okay, now if I use my negative, absolute value, 2 times a negative 8 plus 5, does it equal 11 as well? 2 times a negative 8 is a negative 16. A negative 16 plus 5 is a negative 11. And since it's absolute value, it changes it to a positive. And so those two are correct. There's now two solutions for this problem because of that absolute value. So the rule is that to drop the absolute value, you have to write two equations. And if you remember that rule, then this section will be very easy for you, and we'll be able to move right on. Let's look at example number 2, because they're going to throw a little wrench into the problem. They're going to say we're not just going to have an absolute value, but we're going to have another coefficient on the outside. So it's 5 plus 2y plus 4 minus 5y, and that's an absolute value, equals 21. Well, we need to isolate the absolute value. So we're going to, I'm going to change colors here. We're going to subtract 5 from both sides, and we're going to get the absolute value. And I'm going to go ahead and combine my like variables, and I'm just going to get 4 minus 3y. Okay, 2y minus 5y is a negative 3y. Okay, and that's going to equal 16. 21 minus 5 is 16 if I did my math correct. Okay, so now I've gotten it down to the format that we're familiar with. We have the absolute value on one side. Everything has been, all like terms have been combined. And now it's time to eliminate the absolute value. So we do that by writing two equations. 4 minus 3y equals 16. That's the positive possibility. And the other one's the negative. 4 minus 3y equals a negative 16. Okay, so I have a positive 16 and a negative 16. Now I could have left a negative on this side. And let me just look at that for a second. We do it for simplicity reasons. But we said that this can be positive or negative. Well, what if let's see, I don't want to make this too messy. What if I was to make it negative on this side? And remember that it's everything inside the braces, or the absolute value, equals 16. All we did is divide both sides by a negative 1. And that basically just made that negative over there and made it easier to work with. Because if you remember, if you have a negative outside the parentheses, you have to do a negative distribution. And there's too many potentials for error, so I think it's just easier to make the right side opposite. Okay, so that's why we do it that way, and that just makes it a little bit more simple. And now we're going to solve. Now, well, we've got a negative on the side, but that's okay. A negative 3y, we're going to subtract 4 from both sides, and we're going to get y equals a negative 4. Over here, we're going to subtract 4 from both sides. It gives me a negative 4 plus a negative 16 is a negative 20. So y is going to equal 20 over 3. Okay, and those are my two solutions. Again, you can go back and check your work and make sure that the equations are still true. In this case, I know they are, so I'm just going to move along. And so watch when you're doing these, and just remember those simple rules to drop the absolute value sign, that you have to have two equations. And we'll be doing that for the remainder of the year and some graphing, so it's important that we understand that concept and apply it.